For the chi-square analysis, I'm going to use the data set, Chapter 17, data set 1. And what they're looking at is the preference for school vouchers. And I'm assuming they, interviewed parents or did something like that. But when you open the data set, you're going to get something that looks a little different. It just says voucher, and then it's got the numbers 1, 2, and 3 in the column. And how a chi-square test works is it looks at proportions, basically, multiple proportions. So you can analyze, several sets of data in a two-way table is what we're looking at. The table that we're looking at for the school vouchers is actually it has one row and 3 columns. But we can do much more than that with a chi-squared. We could have, the for, maybe, against, but then we could also break that up into different schools as our rows. So we could have school 1, school 2, school 3, and that type of thing. But for what we're doing, for this one, we're going to just look at the for, maybe, and against. And what they did is they put the data in column 1, and the ones are those that are for the voucher. So if you scroll down here, we have 23 that are for the voucher. And if you look at the data set, they've got it actually written out in a two-way table on page 303 in your textbook. And you should have 23. There should be 17 maybe. So if you look, we should have 17 different 2s. And against, there were 50 of those. So you should have 53s in the data. So to run our chi-squared analysis, we're going to again do a 4-step problem because we are actually testing. So our first step is our state. And when we run a chi-squared test, we're just looking at the proportions, and we want to look at if there is a difference in the proportions. In proportions of opinions on vouchers. And again, the purpose of a chi-square test is so that you can look at multiple proportions. Instead of just being able to compare 2 different proportions, you can compare 3 or 5 or 10 or whatever the case may be. So it's kind of like the ANOVA, how the ANOVA goes with means. The chi-square goes with our proportions. So our plan step, which may look slightly different than the hypotheses in your book, but the plan step, our null is that all the proportions are equal. So the proportion for, what were our different categories here? Proportion for, maybe, and against. So proportion for equals the proportion that was maybe equals the proportion that was against, meaning there is no difference. All 3 groups have the same proportion of people that feel that way. Our alternative is that not all proportions are equal. And that is because we're looking at, 2 of them may be very similar, but the other 2 may be statistically significant in their differences. So we can't say that P is not equal to P, not equal to P. But we can say that not all proportions are equal. So go ahead and open up your data set here, your Chapter 17 data set 1. And we're going to go to Analyze, Non-Parametric Tests, and we're, you can choose Legacy Dialogues, which I know is kind of strange, but Legacy Dialogues, and we're going to run the chi-squared. Okay, we're going to take voucher, and we're going to put that in over as our test variable. And that's it. Then you just click OK. I'm going to double check, make sure they've got everything selected here. Okay. And there is our results. So our first thing that we want to look at down in our test statistic, and I'll talk about the observed versus expected count here shortly, but our test statistic, we have a significance of 0. So that tells me that there definitely is a difference within that data. Okay. And then our chi-square value of 20.6 is fairly high. And again, the chi-square, very similar to our EPSTAT with our ANOVA, is that it's relative to your data. So a 20.6 might be really high in this data set, but in another data set it's really low. But the way I look at it is that a high chi-squared will support a low p-value. So since our p-value is very low, we would assume that our chi-squared is very high. Excuse me. My pen's being a ghost here on me. The other thing we can look at our data set, come back. is our voucher area here. And it tells us what our observed values were under each category, what we would expect those to be in order for all our proportions to be equal. So if we were to equal everything out, we would expect each of these to have 30 people in them. And then our residual tells us how far away our observed counts are from our expected counts. So you take your observed minus expected. So the higher the residual, the farther that number is away from what we would expect. So obviously our against, we have a residual of 20. So that tells me there's probably a pretty good difference there because that level is so high. You could follow this up with a couple T-proportion tests. You can compare the against to the for maybe, or the against to the maybe, because notice how the maybe is much lower. It's got a very low residual, where the against has a very high residual. That tells me that those two probably have a pretty good gap in between them. So you could run a T-proportion test on those two to determine if those who are against is greater than those who chose maybe, and that type of thing. But to finish out our chi-squared here, we've got a significance level of 0. You would copy and paste those tables into your solve step. And then our conclude is, since p-value, wow, I can't type today, excuse me, value 0.000 is less than 0.05, we can reject the null and accept the alternative that there is a difference in proportion of opinions. Okay, and that would be the end of your chi-squared test.